All right, so we are in the final 2 weeks of class. The last week will be devoted to project. So there'll be a lecture and a lab today. I don't know what there will be on Wednesday. There's at least one more topic I'd like to talk about. I don't know if there will or won't be a lab, but next week is all time for you to work on project or to do labs, but it will be me walking. I won't be lecturing or giving any new labs next week. It'll just be catching up or work on your project. Okay. Who was that? Mark.
Blom.
All right. So let me just have a quick peek at the syllabus to remind you as we're getting close to the end. That we've had 2 tests and the final, each one is worth 15%. Homework is 15%, labs are 30%, that there's this project, 10% that you have the last week to work on. Okay. Now I'm going to labs, any late homework or labs from, say, the time of the first 2 tests, they're still worth 90%. So there's still a lot of points to be had, even if you're behind. And let me ask if there are any questions before I start presenting the new stuff. All right. So I'm going to show 2 things today. One is we've been doing some querying. I'm going to show you some variations on queries. And then I will show you a form for deleting an item from a table. And I'm going to just use this simple little 1-table planets database as my example. So I zipped up the structure. Delete that. Get this out of the way. There we go. So this is like what I expect you, this is what I send you and what I expect you to send me. Any static or template files involved with the Flask and all the various Python files and maybe the database, although there's a file in here, I'll probably delete the database and then use the load file to bring it back. If I have that, if I keep that, that's the folder structure of my SQLAlchemy and my Python and my Flask. So if I keep that structure, then I can just paste it into my virtual environment and I'm ready to go. I don't need to copy the scripts or the bin file. Some people have been sending me that. One, it's quite large, so it takes time, a lot of time for you to upload. So you don't want to send it to me because it takes a lot of your time. It takes a lot of time for me to download it. It causes a security violation and I get yelled at and you get yelled at by LaSalle IT. So we don't want any of that. So these are the files that you've done something to, and so they're the ones worth sending. I have an installation, you have an installation, you don't have to send me the installation files. Okay. And so this is also where I grade, so I have a lot of stuff, but it's all this planet stuff that we're going to be looking at. So I'm going to open up Studio Code. I'm going to direct it. That's probably already directed there, but I'll make sure I'm opening the folder that is the SQLAlchemy stew VENV. And then I'm looking at these planet files. So I'm going to be focused on other ones, but let's remind you where we are. I have a definition file that is going to define my database. In this case, there's one table. So keeping it simple. I have one table for planets. It has an ID, which is the primary key, which is an integer, so it'll be auto incremented. There's a name, a distance, and a period. I'm probably going to come in here and delete the planet database. There's the planet database, I'll delete that because I'll generate it again. Because one of today's thing is deleting, and so I deleted some planets and I need to bring them back so I can delete them again. Okay, so this is our one file that defines the database. Then I have another file that is for loading the database from a text file, Kepler, which I have in data. And this is just a Python. It's not a Flask. So I'm just going to run it from the arrow here. And that ran through, it print some stuff out in the terminal, and it also should have brought back my planets DB, should be back. There's my planet DB that's back. If I want to look at my planet DB, remember that in extensions, I had searched for SQLite and found this Alex CVZZ file, and I already have it installed. You can see by the gear rather than the blue install. And then to run that, I do Control-Shift-P, and then from the list of things, I'm pulling out SQLite, open a database, and I wanted to open the planets database. I have a number of your databases and some of my databases. And then that should appear. I'm going to close extensions and view the Explorer, and then that SQLite Explorer appears down at the bottom, and it's got the one table planets. So I expand the database. It gives me the planets table, which if I right click and show the table, there are my planets: Mercury, Venus, Earth, Mars. Okay. So that was, again, I had the, this app planet is an old one when I was doing everything in the beginning in one file. But now I'm separating things out. So here's app planet define, that defined the database. There was load, and that brought in the data. And now I'm going to turn my attention to queries. So I'm just going to, again, not do any Flask just yet. I'm going to write some queries about this database. And there's nothing too terribly exciting because it's just a one table database. But I just want to show you some variations on the output of queries and so on. So that is here. And again, this is not Flask. Here I am importing my definition of database. I'm going to query the database. So I set up a session in order to query the database. And the first query is just this simple session query, and here's my planet table. And since I imported it and called it my_db, it's my_db dot planet. So I'm just querying my one table. I'm getting all the results and looping through them. So that is my first query, just the sort of straight out, what does a query look like? And it's not, this print is not going to be very useful, because the result is going to be a bunch of objects. a list of objects. And so not terribly exciting in terms of when you say print out an object, what you get is some like memory location or something like equally useless. And so this is not going to be very useful at all, but I just want to show you what the raw result was. Then I'm going to, in the second query, I'm going to cast it as a dictionary. And so then instead of printing the items, so it's the same query, but instead of printing simply the item, I'm going to cast the item. This is 2 underscores. You see my cursor in there in the middle of this. So it's underscore underscore. So I'm cast the item as a dictionary. And so then it will, instead of, it was an object, and the object had properties and had names. And then when I turn it into a dictionary, it's going to be these name value pairs. So let me run it. This, what you see there, is from running the load. I had a printout in the load, but now let me run my queries. And let me scroll up to the first one. Here is the raw. So the very first query was just query the database, spit out the results. And it was a list of objects. And here is just this crazy that there's an object and here's like its memory location. Not at all sort of useful to us, but that's what a raw query produces. Now I'm taking those objects and casting them as dictionaries and printing out the dictionaries. So now I have curly bracket. That's our, in Python, that's the beginning of a dictionary. And then there are these name value pairs. So there's this crazy name, underscore SA underscore instance underscore state, and then the value for that, which is that all that crazy crap about that it's an object and here's its memory location. Then we have the more useful part of the dictionary for us, the names and the values of the properties that are in the database. So the name was Mercury, the period was 0.76, and the ID was 1, and the distance was 0.579. Okay, so that is, it could be useful for us to cast the query results as a dictionary, which is what we often do. Because just the pure object is difficult, but the dictionary is a little more what we're used to working with. All right, so then what's my next query? Here I'm, again, just querying the database, but I'm explicitly, I know their properties. So up here, when I was printing out, I didn't refer to their properties. I just said, take the whole thing, cast it as a dictionary, spit it out. Down here, I'm going to say, I know what, I'm going to not do the dictionary thing, but I'm going to say their objects, and I know their properties. So item is an object. So I know I had a list of objects. And so item is an object, but I know it has properties of ID, name, period, and distance. It had another property, this crazy underscore SA thing, and I'm not interested in that. That's just sort of some kind of internal workings that it needs, but it's nothing that I need. It's nothing about, you know, the planet Mercury in that field. So again, so here is, in this third query, I'm explicitly using the names of the properties that I know. All right. So those were all, in terms of the database, just a simple query on the whole table. So query the table, query the table, query the table. The first one, I just spit out the results as they were, which were a list of objects. The second one, I casted the objects as dictionaries and printed that out. So that gave us more information. And then on this third one, I kept them as objects, but now I know the properties of the object. So I could explicitly refer to the properties of the object. This number 4, I am changing the query. So this is the first time the query is actually different. So it's the query that's different rather than the Python that's different. And so I'm picking the fields. So all of my previous queries have essentially been like the equivalent of SQL, like select star. Just get me everything, get me all the records. Now I'm picking out the things I want from the database. So I'm only asking for the name and the distance. Okay. So everything before has been the equivalent of select star, get me everything. Now I'm picking out the fields I want. Planet is the name of my table. My definition is another file, so I refer to it as my_db.planet, and then name was one of the properties and distance was one of the properties. So now I'm just pulling out 2 fields. And then I'm saying, show me the item. It's still going to be some crazy object, so kind of useless. I can explicitly say, well, no, I'm not sure that is true. Let me. This is. Cast as a dictionary. That's the explicit names. Oh, here's the query selected fields. Okay. When I queried the selected fields, my apologies, it was not an object. Now the items are tuples. So when I specify what fields I want, I get a tuple. So it told me the name, I asked the name and the distance. And so now when I specify the columns I want, what comes out is a tuple. So again, you query different ways, you get the data in different formats. The original query was giving me an object. I can pass that object as a dictionary. If I tell the fields what fields I want, then I get a tuple. So the parentheses tells me that's a tuple. And then one of those properties is the distance. So that's telling me I can say item.distance. So within the tuple, it's not showing me the name. It's not showing me the name of the field. It's just giving me the data when I just say print item. But it does know one of those things is called distance. So if I say item.distance, it gives me the distance. So I can refer to it by property name. Or I can use its position within the tuple. So I can say item.distance, that will give me the distance, or I can say item square bracket 0, that will give me the first thing, which was the name, which was Mercury. And I can cast my tuple where the names are hidden as a dictionary. And it's different if you're casting an object as a dictionary. There's a change in notation. When you cast an object as a dictionary, and there you're sort of casting down, then it's __ dict __. But when you have the tuple, you're sort of casting it up, and then it's _as dict, open close parenthesis. So there's these little nuances in which way, the sort of direction you're working in. But either from the object, I can get a dictionary, or from the tuple, I can get a dictionary. So when I say bring it out as a dictionary, then it's going to give me the name value pairs as in a dictionary form. So when I specify the fields, its default result is a tuple. I can extract individual properties from the tuple using the name of the property or the position of the property. And with those names, to get those names sort of more explicitly shown, I can cast it as a dictionary and get it back into a dictionary form. Okay. So what is this next one? There's going to be a filter on distance. So now I'm asking for the name and the distance. So I've specified names. And then this is too long, but I'm filtering on the distance. So that's like a where in SQL. I'm saying where the distance is greater than 10 in whatever units the distance is in. So my query specifically asks for the name and the distance. And then I'm filtering, this is a where clause, and I'm asking that the distance property be greater than 10. So that result is down here. Query selected field from planet table, filter on distance. So the distance had to be greater than 10. So that was Saturn, Uranus, Neptune, and Pluto. They have the bigger distances. And I just used the item, which produced the tuple format. Last one in this list, I can rename my fields. Another thing you can do in SQL, I can say select ID as product code, something like that. I can sort of change the name of the field to what I want it to be. So here's a query. I'm asking for the name of the planet, but I've decided to call it planet name. And I've asked for the planet distance, but I've decided to call it radius. And then I'm showing that I can use these names. So I'm referring to this as dot radius, and its name in the database is not radius, but distance. So, but this query has changed the name, so radius will make sense. And if I cast it as a dictionary, it will give me the new names. And that's down here. Here are my planets. I took off the filter, so it's again back to all the planets. So Mercury. Here is now the radius. Again, that's not the name in the database, but that's the name in the result of these queries. And then I cast the items as a dictionary. It was a tuple, now it's a dictionary. And you can see the names are now planet underscore name and radius. So so that's some of the things you can do in SQL, and we don't want to lose. We want this SQLAlchemy to do the SQL work for us, but not to lose any of the functionality of SQL. And so the point of this demonstration here is to show us getting back some of the results in SQLAlchemy that we know we can do in SQL. Renaming, where clauses, the naming of files, and then there's also all this Python-y stuff of the different ways to access the information. I can get objects, I can get tuples, I can get dictionaries, I can work with indices and say I want the first, second, or third item in the result, or I can work explicitly with the names of the fields. Okay. Any questions? No. All right. So the next thing I want to do is add a delete. So I want the user to be able to do that. So I'm going to add a form. I'm going to add a route for that form, an HTML page for that. So, well, let me do it, and then I can tell you all the new things and actually point to them. Okay, so I'm going to add a delete form to this planet thing. So I have sort of all the parts all over again. I hope I have all the parts all over again. And this is the database with planets missing, so I have to delete it and refresh it. Copy that 341 VENV, paste it in there. Okay, so that should have added a am I seeing it? Did I add it to the right place? App planet. Here's my delete. Oh, it's one of the routes. That's why I'm being silly. Looking for something called delete, but it's not called delete. There should be a forms planet now. The only thing we did before in terms of Flask previously was some table work, which didn't have a form. So we had done things before where we had inserted things, but not on the planet database. So I didn't have a forms planet, but I do now. Okay, so I'm bringing in the usual Flask stuff. I'm going to have a select field. I don't really need a string field. I don't. Yeah, that's kind of a slightly different color because I'm not using it, and I'm not using any validators. So this is me being lazy and not getting rid of the imports I'm not really using. I have a select field. I'm going to have a drop-down list of planets, and I have a submit field. I'm going to press the button when I want the planet deleted, and that's all I really need. I'm not doing any validation, and I'm not doing any string fields. I'm connecting to the database here. I'm making a list of the planets to put into the drop-down list. I think the last time I did that, I made my list in the app, in the routing file. Here I made it in the forms file. It's probably better in the with the other position, but anyway. So here's me querying the database and creating the tuples. The ID is what's hidden and the name is what shows. So you'll see Earth, but behind the scenes there'll be an ID, and then you'll use the ID for deleting. And then here's what's in the delete planet. There's a select field, and it's going to display the names of the planets, but give you the ID. So I called it planet ID, and there will be a submit button. What am I adding here? In the queries, in the planet, not the planet queries, in the planet routes, we can make a table. The default route takes us to table. We'll look at the table. We can also look at it as a data table. And now here's the new part. There's a route for delete. And I'm getting the form from deleting. I make a note here that I redefine the definition. So there was a change in definition. So app planet definition. I added to this, it wasn't just planet.db anymore, but there was this stuff about checking the thread, that when you're going back and forth and you have pages connecting to a database, they would like, it's safest if everything's done in the same thread. That was making life too complicated, so I just said, don't check that it's in the same thread. So that's what this is about. So there was a change to the definition. While I'm thinking about that, let me rerun load. Let me kill the planets and then reload it, because that planet database was missing a few planets. So I want to load them back up. So planet database is gone. Now I'm going to run planet load and load up my planets again. The Flask I usually run from the command line, but this is not Flask. This is just Python and SQLAlchemy. So I'm just going to run this from the run. And I don't know if I ran it or not. Let me look at the table and let me delete it one more time. And so planet is gone. Then I'm going to load it. There, okay. So I did run it. Now here, this should be back. And I have my planets. Okay. So I was telling you about queries, but there was a comment in query, not in queries, in routes. So I'm going to, this route is going to be about deleting. So I needed to import the delete form. And I could put that at the top. Normally I put all my imports at the top, but since I've been sort of adding as I go along, I wanted to put this import near what needed it. So the planet, the route for deleting is the one that needs the delete form. So I decided to put it near the thing that needs it. I don't know if that makes sense or not. Here's my route. Here's the definition for my route. Here's me declaring a form of the type I defined on the other page. I sometimes have valid on submit, but I also try to keep an is submitted. This is the easier one, just are you coming from a form? This is the one where the form has to be valid. So I try to keep both ifs there. I try to use the more sophisticated one, but if it doesn't work, I go back. So that's why they're both there. And it said at one time it was kept coming back as invalid. So that's, I had this is submitted there, but now it seems to be back to working. So, okay. I'm getting the request form. What's in the request form is the ID of a database of a planet that I want. So an ID of a planet in the database that I want to delete. And so I choose it as the planet to delete. I'm going to the database and I'm finding that planet. So I'm going to the planet, I'm going to that database, to the planet table, and I'm getting the object with this ID. And then I just print out that I'm going to delete it. And then I say what the name of the planet I'm going to delete. So that's just down there in the console, in the terminal. And then here I am deleting the planet and then committing. So if I don't commit, it doesn't happen, or it looks like it happens and then it doesn't really happen. So that should be, I deleted the, and then I'm requerying the database and putting the results out. Result dictionary as a table. And then I'm sending that over to my planet data table. So I'm not going to have some form that just says, hey, you just deleted Pluto, which I could do, but I didn't. Instead, I sent them back to the data table with, after requerying the database. So I deleted, I committed the delete, I requeried the data table, the table in the database. And now I'm sending those results over to the data table. And so I should see the data table with the planet I deleted now missing. I asked you in lab just to have some kind of handler. So you can just say this, such and such was deleted, and that's fine. Or deletion complete. You just should have some kind of handler that says something happened. Okay. What else do you need? This is a form, so we should have something in templates for planet. So there's a planet delete form. And so it's the normal form stuff. Here's a place for the drop-down list, which I call planet ID. And here's the submit button. So that's all it's going to be, is a drop-down list and a button. And then I don't have a handler because I'm sending them to the data table. Okay, so let's have a whirl at this. This is Flask, so I'm going to do a more Flasky type of a thing. App planet routes, that's the Flask routes. That's what I want to run, then Flask run. And I spit some stuff out. And then I'm going to, my default route is the table. So there are the tables that I made of the planets. I have another route, which is a data table. This is the one that's searchable and sortable. Okay, and then I also had a route which was planet delete, I believe. That's the new one. Planet delete. So my new route is planet delete. It is a drop-down list with the planets. Of course, I'll pick on Pluto, and then I will say delete the planet. And the handler was a data table after I requeried the database. So I requeried the database and sent it to data table. And here it is now showing me the results without Pluto. That makes sense on a small table like this with like 9 entries. You can sort of see, oh, Pluto's missing. If you have a lot of stuff in your data table, that doesn't make sense. Then the person's going to have to go searching for, now I did choose data table, so I can search for it. Is Pluto here? No, I'm not finding anything. So it's not completely absurd, but it may not be the best handler in most cases. It made sense here because it was a short list. If there's a longer list, you might want to just say deletion complete. All right, that's what I wanted to show you. And of course, you have to do something similar. You don't have to do any of the query stuff, but you do have to do a delete. I wanted to keep it somewhat easy, so I chose a database you already had, or should have, or will have soon. That's your poet and poem. And if you were to delete a poet, you would have to worry about what should happen to that poet's poems. And I didn't want you to have to deal with that. I just want you to do a simple delete. So I'm having you delete a poem, not a poet. You have to worry about what happens with the cascade. If you delete a poet, you have to worry about what should you do with that poet's poems. But as I say, I didn't want you to have to deal with that. I didn't deal with it in my planet since there was only one table, so I didn't want you to have to deal with it. So from lab 20, you're supposed to have a poet poem. It could be song and lyricist database. If you don't like poems, but you like songs and lyrics, same thing. Then we're going to add a form, and you might not have any forms. That was mostly just database stuff, but add a form that allows the user to delete one of the poems. And then, so you're going to need a form. If you don't already have a form for that database, you're going to have a form. In your routes, you're going to have to add a new route. You have some routes for inserting poems and poets, but you're going to have to add a new route for deleting and an HTML page for handling deleting, maybe some title of the poem in a drop-down list or something. So, and then some kind of handler. And it's good enough for you to just say, it got deleted, bye-bye. So that's what you're to do. So you should already have this. If you're caught up, you already have this, the definition, you already have the load, you have an insert, you're going to add a delete. Now, if you have an insert, then you already have forms. You're just not going to have to add a new form, a delete form to it. You're going to have to add a delete route and then the HTML page and the handler. So not too bad. Okay, so that is that. Any questions for the recording? Hope I'm recording. I am recording. Nothing. All right, so I will stop recording. Let me make sure I got everybody. No, I don't have everybody for attendance. Now, let me see.